Hi everybody, in this video we will continue looking into AC generators. Last time we derived our equation for the EMF of an AC generator being the EMF produced is equal to the angular velocity times by the number of coils times by the magnetic field times by the area of the coil times by sine the angular velocity times time. Now we're going to see what our EMF actually looks like graphically. On my y-axis, I'm going to have my EMF measured in volts. On my x-axis, I'm going to have time measured in seconds. Now that I have my axis set up, I need to talk about which position the coil is going to be in. Let's start off with our coil being in a horizontal position. I'll change the color of one of these wires so that we can tell how the coil is moving. I'll change the color of the left one. With this position of our coil, starting at time is equal to 0, our EMF is going to be equal to 0. As time passes, sine omega t will vary between -1 and 1. When we rotate our coil 90 degrees, we're going to be at our maximum when sine is equal to 1. From our initial position, it's going to follow a sine curve and go up to its maximum EMF. Now rotating the coil another 90 degrees, we are back to the same orientation, however flipped by 180 degrees. So our EMF is going to go back to 0. Our coil will then rotate again by 90 degrees. This gives our EMF at its maximum negative. The coil then rotates in its final 90 degrees, bringing it back to its starting position, and the EMF returns towards 0. This simulation to the right shows us the coil spinning in a magnetic field. Notice that the orientation of the magnets is different to what we have been discussing so far. So what is this maximum and minimum EMF? I'll note these on the graph with an epsilon naught. From our equation of EMF, the sine component will alternate between -1 and 1. This means that our maximum EMF, epsilon naught, is going to be when sine omega t is equal to 1, giving us that epsilon naught is equal to the angular velocity times by the number of coils times by the magnetic field times by the area. So the current produced by an AC generator is going to be determined by Ohm's law, where our current is equal to our voltage divided by our resistance. This gives that our current is equal to our maximum EMF divided by our resistance of the circuit times by sine the angular velocity times by time. This is where our maximum current is going to be equal to our maximum EMF divided by our resistance. From this we can see that our current is following a sinusoidal pattern as well. In fact, it follows the same sinusoidal relationship as EMF. So for each one of these coil positions that we have, whether it be horizontal or vertical, we will actually have the current being exactly the same. So our red line here denoting our EMF produced can actually be used as well for the current. The next thing I want to put onto our graph is the magnetic flux of the AC generator. From our previous video, we found that the magnetic flux is equal to the number of coils times by the magnetic field times by the area times by the cosine of the angular velocity times by time. Now that I've got that, I'm going to be graphing our magnetic flux, which has units of Webers. With this one, we can see that we have a cosine relationship. So, at the beginning, when we have our coil being horizontal, we're going to have a value of 1. That is to say, it's going to be at its maximum. Then, once it goes to its horizontal position, by rotating 90 degrees, it's going to be equal to 0. Further rotating it by 90 degrees is going to give us a maximum negative number. Rotating it again by 90 degrees is going to give us 0 again, and then we are back to the beginning. So this is going to look like a cosine wave. We can see on this that when we have the maximum amount of magnetic flux, we have no EMF or current passing through. But when we have a maximum amount of EMF or current, we have no magnetic flux. This pattern repeats as the cycle continues. All of this information gives us the reason of how the two systems AC and DC are different. Direct current always moves in the same direction, and that electrons are moved through the circuit. Alternating current moves the electrons backwards and forwards with the same frequency as the voltage. For Australia, this frequency of electricity in a domestic household is 50 Hz. In summary, we've looked at the EMF and current produced by an AC generator. We've related this to its magnetic flux and position of its coils. Thank you very much for watching. See you in the next video.